So, for example, sine theta equals a with a greater than 0. Well, a is greater than 0 if s is greater than 0. Right? So in the CS plane, you get one of these two triangles. Because that's where you get positive signs. So you get theta 1 or theta 2. Theta 2 is related to theta 1 in that it's pi minus theta 1. Theta 1 is actually the reference angle for theta 2, in fact, in this case. So there's these two different angles that you have to take into account. Remember, you're solving for the angle here. So if sine theta equals a, if a is negative, then s is less than 0, and so you're down in one of these two triangles. And those, again, differ by this relation. These are what we call supplementary angles. They add up to pi, or 180 degrees. So theta 2 equals pi minus theta 1. And you can just see that by drawing the pictures. I always draw the pictures, and then I don't have to memorize this kind of stuff. But whatever floats your boat, do whatever works best for you. So there's supplementary angles for sine. Sine supplementary angles. So for cosine theta equals a. If a is positive, then the coordinate c is positive. And that gives you one of these two triangles. And these are actually, the angles are actually opposite of each other. So theta 2 equals negative theta 1. So this is kind of like the y equals x squared. You're going to get a plus and a minus when you solve for the angle. If a is negative, then c is negative, right? And you get one of those two triangles. And again, those are opposite triangles. They're just in quadrants 2 and 3 instead of in quadrants 1 and 4. So notice the difference here. With sine, if you have an angle theta 2 or theta 1, then you get theta 2 by finding the supplementary angle. For cosine, you just take the opposite angle to find the second one. Tangent theta equals a. Tangent is opposite over adjacent. If a is positive, then you get positive over positive or negative over negative. Those are the two possibilities. And those end up in quadrant 1 or quadrant 3. And so those two angles, they differ by pi. The difference is pi. So theta 2, the second one is just pi plus the first one. Now if a is less than 0, then the opposite is positive and the adjacent is negative, or the opposite is negative and the adjacent is positive. In other words, they're opposite signs, and that gives you two triangles, in one in quadrant 2 and one in quadrant 4. Notice for tangent, these terminal sides are always opposite. So again, theta 2 equals theta 1 plus pi. Notice that for tangent, theta 1 and theta 2 differ by the period of tangent theta, which is just pi. And so that'll be important later, because next we're going to look at how we get multiple solutions from the periods. And it turns out that for tangent, we can kind of ignore this fact that we get these two different triangles in many cases, because we're just adding on multiples of the period anyway. So the first one, so the second one gets absorbed into that, I should say. Okay, so the triangle for the other trig functions like secant, cosecant, cotangent are the same as the quadrants, are in the same quadrants as their reciprocals. Okay, so you can just treat them essentially the same. So reciprocal of cosine, remember, is secant. So secant will act like cosine. Cosecant is reciprocal of sine, so cosecant will act like sine as far as these angles go. And cotangent and tangent act similarly.